Welcome to Time to AI. I'm Jason Turpin. This is the first video in a series of foundational videos covering various aspects of the ecosystem surrounding generative large language models. Over the series, I'll cover large language model not-so-basics, that's this video, products such as ChatGPT, which are based on large language models. Note, ChatGPT isn't a large language model, it's a product. Large language model development patterns, prompt augmentation via RAG or retrieval augmented generation, and finally, how LLMs can be extended through training. Anyway, this video is about the large language model itself, the what and the how. Let's do this, Leroy Jenkins. Large language models are a type of artificial intelligence that process and generate human-like text by learning from a vast corpus of language examples. I'll get into that in the how section. First, I wanted to talk about the two major types of models, proprietary and open. First, you have the proprietary large language models. These are the flagships in terms of capabilities. These include OpenAI's GPT-4, Google's Gemini, and Anthropic's Claude Opus model. They are accessed via APIs and pricing generally on consumption. They offer limited custom training scenarios. For example, OpenAI allows custom training for GPT 3.5, but not GPT 4, although that is coming, but appears to be quite expensive. Next, you have open models. There's one particular major model here, Meta's Llama 3. It outperforms GPT 3.5, but it trails GPT 4 with regard to performance. There are many other models of various sizes and purposes, noticeably Bloom and BERT, and Hugging Face will overwhelm with over 600,000 models available. The key differences comparing open models to proprietary models is that you download the actual models and run them on local or cloud hardware. This is a more complicated scenario by far than just calling an API for proprietary models. But for absolute beginner testing, you can get by performing inference on CPU, although it will be very slow. Open models can also be trained without limitations or restrictions of the proprietary models. I've run several open models but never performed any training. I focus on the more powerful proprietary models, specifically GPT-4. So there's a high-level overview of the current state of powerful and popular large language models. Now let's talk about the how. I'm going to start with a metaphor for this to set the stage. Imagine that the large language model itself, the neural network, is an orchestra where each musician is a parameter. The conductor is an attention mechanism guiding the musicians. Backpropagation is the musician's practice and refinement of their performance based on the conductor's feedback. With that in mind, let's talk about the orchestra itself, the large language model. Here's a definition. A large language model is a type of neural network called a deep learning model. The neural network typically consists of a series of self-attention mechanisms that allow the model to weigh the importance of different parts of the input data differently, enabling it to generate contextually relevant outputs. That's a lot to take in. Hey, there's that phrase attention mechanism. That's the conductor in our orchestra. Another definition incoming. An attention mechanism is a process that allows the model to dynamically focus on certain parts of the input data that are more relevant. It does this by assigning different weights to various parts of the input, which determines how much attention the models should pay to each part when making predictions or generating outputs. Okay, the conductor gives attention to certain musicians, which are parameters. The parameters represent a weight value, and in certain situations that parameter is activated, so the musician plays. Finally, the metaphor mentioned backpropagation, as the musicians practice and refinement of their performance based on the conductor's feedback. Here's the definition, but keep in mind that this is basically the training. Backpropagation is an algorithm used in neural networks that adjusts the weights of connections by propagating errors backwards from the output layer to the input layer to minimize loss and improve model accuracy. The process is trying to get the parameter weights aligned so that inputs produce expected outputs for training data. This one gets its own metaphor. Backpropagation is like trying to find your way out of a maze. You make choices at each intersection adjusting the weights. Those are the parameters. And when you hit a dead end, an error beyond a certain threshold, you backtrack and try a different path until you find the way out. In this case, you want the expected output to be close to the expected output. So that's the more orchestra metaphor for large language models. And now, let's just metaphor the whole thing to death. Data processing. This is akin to the rehearsal space for an orchestra, providing the essential environment for harmony. Learning algorithms. Comparable to the music scores. They guide the performance of the system. Training data. This can be represented by the initial auditions for the orchestra members, setting the foundation for what the system will learn. Model architecture. Similar to the arrangement of the orchestra, it determines the structure and flow of the system. Output generation. This is like the final performance, the end product of the system's processing and learning, using the model. And yes, GPT-4 put quite a bit of that together for me on that metaphor expansion. GPT-4 is fantastic at metaphors, and metaphors are fantastic conceptual translations. Anyway, that's a bit, not a little, not a lot, of information about what large language models are. And that's it for this video. I hope you found it interesting and instructive. Look forward to the next one, I hope. Like and subscribe, and until next time, have a good one.